Ask My Instructor 8.4.11. Evaluate the following integral. To evaluate this integral, we're going to use a method called partial fractions. To use partial fractions, the first thing we do is factor the denominator. The denominator is a quadratic. It's a difference of two squares. When we factor it, we get 4 minus 5x times 4 plus 5x. And we use the information to set up the partial fractions. Put a over one of the linear terms and b over the other linear term. It doesn't matter which we choose for a and b, we just need to be consistent. Multiply both sides of this equation by the denominator 16 minus 25x squared. On the left-hand side, we will get 1. On the right-hand side, we will get a times 4 plus 5x plus b times 4 minus 5x. So when we multiply both sides of this equation by the denominator, we get the equation 1 equals a times the quantity 4 plus 5x plus b times the quantity 4 minus 5x. What we're doing here, in case you're confused, is we're trying to figure out what a and b are. So the first thing that we did is we cleared the denominator. Equations are always easier if you don't have a denominator. We have now successfully cleared out the denominator. Alright, so this is what we're going to do next. We distribute and combine like terms. In my next step, I'm going to put 1 over on the right-hand side so that it's equals 1 instead of 1 equals. I'm also going to rewrite 1 in this manner. Instead of 1, I'll have 0x plus 1. Now, this seems rather odd. I'll show you in a minute why it matters, but right now make sure that that everything I did is legal. By rewriting like this, we see that we must have equal coefficients for the linear terms. I have a linear term on the left-hand side and a linear term on the right-hand side. Those two terms have to be equal, which means the coefficients have to be equal. In a similar manner, I have a constant on the left-hand side and a constant on the right-hand side, and those two constants have to be equal. This gives me two equations. I have two equations, two unknowns. I'm getting closer to finding out what a and b are. The first equation tells us that a equals b. Using a equals b in the second equation, I get 4a plus 4a equals 1, or solving for a, I get a equals 1/8. Since a and b have to be equal, we also know that b equals 1/8. Now we have to go back and remember which linear term we put under the a and which one we put under the b. In this particular case, it doesn't matter because a and b are equal, but usually it does matter. So we rewrite it, and this is what we get. Now that we have broken the integral up into two separate integrals, we are going to turn our attention to the two manageable pieces. We are going to do each integral separately. Let's do the first one first. This integral, look at your denominator. Have that be u, then du equals negative 5 dx, and dx will be substituted with negative 1/5 du. Do the substitution. The antiderivative of du over u is ln of u. Now substitute back. And this is what you get for the first integral. Let's do the second integral. This time have u be 4 plus 5x. Do the substitution. The antiderivative of du over u is ln of u. Now substitute back, and this is what we get. So we have easily integrated both pieces. And the only thing we want to do now is clean this up. Lots of different ways to clean this up. I'll just show you how I do it. First off, I switch the two terms so that my negative comes second. That's just a personal preference. I also bring out the 1 over 40, so I distribute that out. Next, I'm going to use the fact that the difference of two logs is the log of the quotient. So log A minus log B equals log of A over B. And this is what I get. Notice the absolute value signs, they are essential. Next, I'm going to use the power rule. I have a log and on the I have a coefficient of 1 over 40. That coefficient, when it's brought into the log, becomes the exponent. And this is my final answer. Before you go, I just want to tell you one more thing. When I did this problem, I got this answer, which MML, my math lab, would probably accept. If they don't, certainly you need to tell me, because they should. However, I did want to point out that MML told the student who asked me about this problem that the answer was this. You might not readily see that these two answers are equivalent. But if you notice that 4 minus 5x, because we're dealing with absolute value, 4 minus 5x in absolute value is equal to, in absolute value, 5x minus 4. And you can agree that the two are equal. But why did my math lab switch it around like this? Well, this could be one reason. Let's go back to a place where we were. This first equation, when we were here at the very top line, we could have used the fact that 4 minus 5x equals negative quantity 5x minus 4. And then we would have rewritten our integral this way. Now, why would we do this? It could have made our u substitution a little bit easier. Also, their answer is a bit better because they are putting their linear term first, which is usually preferable. However, I don't think it's a huge issue, and as I said, my math lab would probably accept both. I certainly will accept both. Have a great day, and let me know if you have any questions.